right, we are back. And so if you have been playing along at home but hitting some bumps in the road, that's totally normal. And indeed, the goals of lecture generally will be to give you a sense conceptually of where we'll be going during the course of the week. But it's indeed through the hands-on labs and problem sets that you'll really have an opportunity at your own pace to work through some of those same bumps in the road. But for today, let me give you a few more building blocks. And these two will translate from scratch initially, namely like conditionals, like how now in C, after knowing now how we can use functions, at least getString and printf, and we can use variables like the string I created earlier. How can I now add to the mix things like decision making and conditionals at that? Well, with conditionals in Scratch, we had this kind of syntax. On the left, here in Scratch is how you might express if two variables, x and y, have this relationship. If x is less than y, then say on the screen x is less than y. Well, let me translate that to the right now in C code. So in C, the corresponding code is going to look like this, assuming x and y already exist. More on that later. And notice a pattern we're going to see again and again. There is going to be parentheses around the x and less than y. So parentheses around the Boolean expression, recall. The Boolean expression is the true, false, the yes, no answer, a question that you're trying to ask in order to decide whether or not to do something. So you use parentheses there. So similar in functions where we used parentheses for printf and parentheses for getString. And this is just a weird inconsistency stylistically. When using the keyword if, you should, as a matter of best practice, put a space after the word if. When using a function like printf or getString, you shouldn't. Both will work, but you'll find that these are conventions stylistically that most people adhere to. So space when using an if here. All right, now inside of the curly braces is where the actual code goes that you want to execute conditionally. So if you want to print out x is less than y only if x is actually less than y, in C, you use this open curly brace, which up until now you've probably rarely used on your keyboard, and the closed curly brace down here. And those are kind of hugging, if you will, the one or more lines of code underneath the if. Very similar in spirit to how the orange block here kind of hugs the purple puzzle piece here. So there's no graphics in C. It's all text. So you can think of those curly braces as really representing the same idea. As a side note, if you only have one line of code inside of the if condition, if you will, you strictly speaking don't need the curly braces, but as a matter of good style, do include them. It will make more obvious what your intent is. How about in Scratch if you wanted to express this? Two ways in the road that you might go, left or right, so to speak. Well, if x is less than y, I want to say x is less than y. Else, I want to say the opposite. X is not less than y in this case. So I'm making a decision based on that Boolean expression. In C, it's almost the same, but you're adding to the mix the keyword else. So MIT borrowed for Scratch the same keyword there, and a second pair of curly braces, open and closed respectively. And you might guess now what goes inside of those. Well, you print out x is less than y, or you print out x is not less than y. All right, what if there's a three-way fork in the road? In Scratch, this actually gets a little unwieldy graphically, if you will. But notice that in Scratch, this is how we could express if x is less than y, say x is less than y. Else if x is greater than y, say x is greater than y. Else if x equals y, then say x is equal to y. Now, minor inconsistency here. Just a little bit ago, I claimed in C that an equal sign represents what operation? Assignment from right to left. Insofar as Scratch is really meant for kids and they didn't really want to get into the weeds of this kind of semantic, equal sign in Scratch means equality. However, we're going to need to fix this in C in just a moment. In C, equal sign means assignment right to left. In Scratch, it literally means what you would expect. All right, let's translate this code then to C. On the right, this code would correspond really to this. And you can perhaps see somewhat goofily what the solution was, not unlike the %% solution earlier when humans painted themselves into one other corner. You say if, you say else if, and you say else if. And how did we resolve the use of a single equal sign already? In C, when you want to express equality, is the thing on the left equal to the thing on the right? You literally use two equal signs right next to each other, no space in between them. But now, this code would be correct on both the left and the right, whether you're doing this in Scratch or C respectively. But now we can kind of nitpick our code, specifically the design thereof. Logically, can anyone critique the design of this code either in Scratch or C? Like, I feel like we could do better? How about in back?
The only option after it being greater than or less than is for it to equal. So I think we can change that the last else is same.
Perfect. Logically, it's got to be the case that x is less than y, or x is greater than y, or by conclusion, it's got to be equal to y. So why are you wasting my time or the computer's time asking a third question? You don't need to ask this final else if, because logically, as you note, it should go without saying. So it's a minor tweak, like you're doing extra work potentially in the cases where x equals y. So we can just refine that. And just like in Scratch, you could just use an else block. Similarly, in C, could we simplify this code to just an else, a sort of catch-all logically that just handles the reality that, of course, that's going to be the final situation instead. All right, so we have this ability now to express conditionals with Boolean expressions. Let's actually do something with this next here. So let me go back to VS Code. I've closed hello.c, and I want to create a second file for the sake of some demos now. Recall that you can create new files by typing code space and then the name of the file you want to create. For instance, I might do compare.c. I want to write a program that's going to start comparing some values for demonstration's sake. But before I do that, let me just show you by opening the File Explorer at right. This is similar in spirit to a Mac or PC. Like you can go up here and click on an icon, and you can click on the plus icon, and you'll get a blue box, and I can type in compare.c, and I can just manually create it that way. Notice that opens the tab even without my having typed code. So again, on the left, you have a GUI, a graphical user interface, albeit a simplistic one. On the right, and at the bottom here, you have a command line interface, but they're one and the same. What's nice, though, is that if I close this file, accidentally, intentionally, whatnot, I can reopen it without creating a new one by just running that same command, code space compare.c. So code is a VS Code thing. It's just a user-friendly shortcut, but it's just creating a file or opening an existing file like that. I'm going to hide the File Explorer just to make more room for code here. And let's go ahead and do this. Let's write a program that compares two values that the human inputs, but not strings this time. Let's use some actual integers. All right, I'm going to go ahead and include the CS50 library's header file at top. CS50.h. I'm going to also include standardIO.h. Why? One gives me user-friendly input via getString, getInt, and so forth. One gives me user-friendly output via printf in the case of standardIO.h. Now I'm just going to kind of blindly type this line of code, which we'll come back to in future weeks. But for now, that's analogous to the when green flag clicked code in Scratch. And now let's go ahead and do this. Let me go ahead and get an int from the user and ask the user, what's x, question mark. I'm not going to bother with a new line. I want to keep it all in one line just for aesthetics sake. But when I get back an int, just like I get back a string, I get back a return value. So if I want to store the result of getInt somewhere, I had better put it in a variable. And I can call the variable anything I want. Previously, I used answer or first or last. Now I'm going to use x. But there's still two things left to do here. Logically, even though we haven't technically done this yet. What do I still need to do? So I need the semicolon at the end and the int at the beginning. You, the programmer, starting today, kind of need to decide what you're going to be storing in your variables, and you just need to tell the computer that so that it knows. Now, as a teaser for languages like Python, more modern languages, turns out humans realized, well, gee, this is stupid. Like, why can't the computer just figure out that I'm putting an int there? Why do I have to tell it proactively? So in some languages nowadays, like Python, we'll get rid of some of this syntax. We'll get rid of the semicolons. But for now, we're looking at really the origins of how this all worked. All right, so I've done this one line ending with semicolon. Let me do one other, and let me get a second int asking the user, what's y, question mark. So almost identical, but different responses from the user, hopefully. And let me just ask simply, if x is less than y, in parentheses, then some curly braces, let me go ahead and print out, quote unquote, x is less than y, \n. And now just as a side note, I seem to be typing kind of fast. Some of that is because VS Code is helping me. Let me go back to this first line with the if, hit enter, and now I'm only on my keyboard going to type the open curly brace. This is a feature of many text editors nowadays. It finishes part of your thought. Why? Just to save yourself a keystroke, to make sure you don't accidentally forget the closing one. So you'll notice sometimes that things are happening that you didn't type. It's just VS Code or future programs you use trying to be helpful for you. I'll go ahead and manually type out now printf, x is less than y, \n, close quote, semicolon. So let me go ahead now and try to run this. And we'll see. Let's see. So make, not hello, but make compare, because this file is called compare.c. Hitting enter. OK, no output is good because it means I haven't messed up. Let me do /compare instead of /hello. Enter. What's x? How about 1? What's y? How about 2? X is less than y. Well, let's try it again. And here I'll save you some keystrokes too. Let me clear my screen. Instead of constantly typing /this and /that, you can also use your keyboard's arrow keys in VS Code to scroll back through time. So if I hit up once, there's the last command I wrote. If I do it up twice, there's the second to last command I wrote. So sometimes if you see me doing things fast, it's just because I'm kind of cheating and going through my history like that. All right, let me go ahead, though, and rerun /compare. Enter. Let's reverse it this time. 2 for x, 1 for y. And now, of course, there's no output. All right, well, that's logically to be expected because we didn't have an else here. So let's add that. Else. Now let's open my curly braces, letting VS Code do one of them for me. Printf, quote unquote, x is not less than y, \n, semicolon. Let me go ahead and try this again. /compare, enter. Again, 2 for x, 1 for y, and we should see, what did I do wrong? Why am I not seeing any else output? Yeah. Exactly. You've got to get into the habit after you change your code of recompiling it. Otherwise, the zeros and ones in the server are the old ones until you manually compile. So let's fix this. Make compare, enter. No error messages. That's good. /compare, 2, 1. And now I get back the output. So x is not less than y. How about if I go and add in the third condition? Well, we can do this either efficiently or inefficiently. Let me go ahead and refine this. So else if x is greater than y, let's literally say x is greater than y. And now I could do else if x equals y, but I think we already claimed that that's unnecessarily inefficient. So let's just have our catch-all. And here I'm going to say, quote unquote, x is equal to y \n, close quote there. So I think now with this code, we've handled all 3 scenarios. Let me go ahead and recompile it properly. Make compare, /compare, and now 1 and 2, x is less than y. Let me run it again. 2 and 1. X is greater than y. And lastly, 1 and 1, and x is equal to y. So for the most part, our code's getting longer. We're up to like 21 lines of code, though some of them are just single characters on the screen. Almost everything else is the same. I'm using the CS50 libraries header file for my getInt function, standardIO.h for my printf function, and the rest of this is just now new syntax for conditionals as well. Questions then on this C implementation of just some basic comparisons like this? Any questions? Yeah. Good question. Do the opening brackets need to be on a separate line? In CS50, yes. What you'll see is that as part of the submission process, we compare your code against a style guide, which is the norm in industry. A company would have its own sense of style and how its code should look. And there's generally automated tools within a company that help give feedback on the code or stylize it as such. There are alternative styles than what we use in the class. We deliberately keep and ask that you keep the curly braces on their own line, if only because it rather resembles like the hugging nature of Scratch's blocks and just makes clear that they're balanced, open and closed. However, another common paradigm in some languages and with some programmers is to do something like this on each of them. So you have the opening curly brace on the same line as here. We do not recommend this. This is in vogue in the JavaScript world and some others. But ultimately, in the real world, it's up to each individual programmer and or the company they're working for, if applicable, to decide on those things. All right, so beyond then these conditionals, what if we want to do something that's maybe pretty common? So almost every piece of software or website nowadays that you use has you like agree to some terms and conditions by typing like yes or no, or just Y for yes and N for no. So how could we implement some kind of agreement system? Well, let me do this. Let me create a new program, a third one called agree.c. So I'm going to write code agree.c just to give myself a new tab. I'm going to start as always now, include cs50.h. Let's include standardIO.h. And then let me do my int main void, which again, for today's purposes, we'll take at face value is just copy paste. And if I just want to get y or n, for instance, instead of yes or no, we can just use a simpler variable here. How about just a char, a character, a single character? So I can use getChar to ask the user, for instance, do you agree, question mark. But as before, I need to store this somewhere. So I don't want a string because it's a single char. I don't want an int. I just want a char. And it's literally char. And then I could call this thing anything I want. It's conventional. If you have a simple program with just a single variable and it's of type char, call it c. If it's an int, call it I. If it's a string, call it s. For now, I'm just going to keep it simple and call it c. And now I'm going to ask a question. So if c equals, how about quote unquote y, then let me go ahead and print out agreed, \n, as though they agreed to my terms and conditions. Otherwise, let's see, else if the character equals quote unquote n, then let me go ahead and print out, say, not agreed, as though they didn't, quote unquote. And let's leave it at that, I think, here initially. Now, you'll notice one curiosity, one inconsistency, perhaps. Does anyone want to call it out, though it's somewhat subtle? I've done something ever so slightly differently without explaining it yet. Do you see it? Yeah, so I've suddenly used single quotation marks for my single characters and double quotes for my actual strings of text. This is a necessity in C. When you're dealing with strings, like strings of text, like someone's name, a sentence, a paragraph, anything really more than one character, you typically use double quotes. And indeed, you must. When dealing with deliberately single characters, like I am here for y or n, you must use single quotes instead. Why? Because that makes sure that the computer knows that it's indeed a char and not a string. So double quotes are for strings, single quotes are for chars. So with that said, let me go ahead and zoom out. Let me go ahead in my terminal window, run make agree, enter. Seems to work OK. So let me go ahead and do /agree. Let me go ahead now and type in y. Here we go. Enter. Let me try that again. Rerun /agree. How about no? Enter. Why is it not behaving as I would have expected? Yeah, I kind of cheated there, and I hit the caps lock key just as I started typing in input. Why? Because I deliberately wanted to type in uppercase instead of lowercase, which is kind of reasonable. Right? It's a little obnoxious if you force the user to toggle their caps lock key on or off when you just need a simple answer. That's not the best user experience or UX, but it would work if I cooperated. Let me run this again without caps lock on. Y, lowercase for yes. That worked. N, lowercase for no. That worked. But how could I get it to work for both? Well, how about this? Let me go ahead and just add two possibilities. So else if c equals quote unquote capital Y, then also do printf agreed \n. And down here, else if c equals single quote capital N, then go ahead and print out again, not agreed. OK, this I will claim now is correct. And I'll do make agree real fast, /agree, and I'll use capital. It now works. I'll use capital. It again works. But this is perhaps not the best design. Let me hide the terminal window and pull this up on the screen all at once. Why might this arguably not be the best design, even though it's correct? There's another term of art we can toss here, like something smells kind of funky about this code. This is an actual term of art. Like there's code smell here. Like something smells a little off. Why? What do you think? Yeah, there's the same output again and again. I mean, I manually typed it, but honestly, I might as well have just copied and pasted most of my original code to do it again and again for the two capital letters. So if line 10 and 14 are the same, and line 18 and 22 are the same, and then the rest of these if and else ifs are almost the same, like there's some code smell there. Like it's not well designed. Why? Because if I want to change things now, just like last week in Scratch, I might have to change my code in multiple places, or copy paste is never a good thing. And God forbid I want to add support for yes and no as full words. It's really going to get long. So how can we solve this? Well, it turns out we can combine some of these thoughts. So let me try to improve the yeses first. It turns out if I delete that clause, I can actually or things together. In Scratch, there's a couple puzzle pieces, if you didn't discover them, that literally have the word or and the word and on them, which allow you to combine Boolean expressions so that either this or this is true, or this and this is true. In C, you can't just say the word or. You instead use two vertical bars. And vertical bars together mean or, logically. And so I can say C equals, quote unquote, capital Y, agreed. And now I can get rid of this code down here. And let me go ahead and say vertical bar twice C equals, quote unquote, N in all caps. And now my program's like, roughly a third smaller, which is good. There's less redundancy. And if I reopen my terminal window, rerun make of agree, /agree, now I can type little y or big Y, and same thing for lowercase and uppercase n. Any questions then on this syntax, whereby now you can combine thoughts and just kind of tighten things up? And there'll be other such tricks too. Yeah? A really good question. Is there not a function to just ignore the case? Short answer, there is, and we'll see how to do that in actually just about a week's time. And in other languages, there's even more ways to just canonicalize the user's input, throwing away any space characters they might have accidentally hit, forcing everything to lowercase. In C, it's going to be a little more work on our part to do that. But in fact, as early as next week, we'll see how we can do that. But for now, we're comparing, indeed, just these literal values. Other questions? Really good question. So we are assuming with this program and all of my last ones that the human's cooperating. When I asked for their name, they typed in David and not 1, 2, 3. Or in this case, they typed in a single character and not a full word. So this is one of the features often of using a library. So for instance, if I run agree again and I say something like sure, enter, it rejects it altogether. Why? Because SURE is a string of characters. It's not a single character. Now, I could just say something like X, which is neither Y nor N, of course, but it tolerates that because it's a single character. But built into CS50's library is some built-in rejections of inputs that's not expected. So if you use getInt and the user types in not the number 1 or 2, but cat, C-A-T, it will just prompt them again. And this is where, too, if you were to do this manually in C, you end up writing this much code just to check for all of these errors. That's why we use these training wheels for a few weeks, just to make the code more robust. But in a few weeks' time, we'll take the library away, and you'll see and understand how it's indeed doing all that. All right, so how about this? Let's now transition to something a little more Scratch-like literally by creating, how about another program here called meow, so meow.c. We won't have any audio capabilities for this one. We'll just rely on print. And suppose that I wanted to write a program in C that just simulates like a cat meowing. So I don't need any user input just yet, so I'm just going to use standard io.h. I'm going to do my usual int main void up here. And then I'm just going to go ahead and do printf meow \n. And let's have this cat meow 3 times like last week. So I'm going to do meow, meow, meow. Notice as an aside, whenever you highlight the lines, you'll see little dots appear. This is just a visual cue to you to let you figure out how many spaces you've indented. VS Code, like a lot of editors, will automatically indent your code for you. I've not been hitting the spacebar 4 times every time. I've not even been hitting tab. However, in C, the convention is indeed to indent lines, where appropriate, by 4 spaces. So not 3, not 5. And these dots help you see things so that they just line up as a matter of good style. All right, so this program, I'm just going to stipulate right now, is indeed going to work. Make meow, which is kind of cute. And now meow, there, 3 times. Correct. It's meowing 3 times. But of course, this is not well designed. It wasn't well designed in Scratch last week. Why? What should I be doing differently? Yeah. Yeah. It's a perfect opportunity for a loop. Why? Because if you wanted to change maybe the capitalization of these words, or you wanted to change the sound to like woof for a dog or something, you'd have to change it 1, 2, 3 places. And that's just kind of stupid, right? In code, you should ideally change things in one place. So how might I do that? Well, we could introduce a loop, yes, but we're going to need another building block as well that we had in Scratch, namely those things called variables. So recall that a variable, like in algebra, x, y, z, whatever, can store a value for you. And a variable in Scratch might have looked like this. You use this orange puzzle piece to set a variable of any name, not just x, y, or z, but you could call it something more descriptive like counter, and you can set it equal to some value. In C, the way to do this is similar to some of the syntax we've seen thus far. You start by saying the name of the variable you want, a single equal sign, and then the value you want to initialize it to. Copying, therefore, from right to left. Why? Because the equal sign denotes, again, assignment from right to left. This isn't enough, though. You might have the intuition already. What's missing, probably, from this line of code just to create a variable? So we need int to make sure the computer knows that this is indeed an int. And then lastly, semicolon as well. And that now completes the thought. So a little more annoying than Scratch, but we're starting to see patterns here. So not every piece of syntax will be new. All right, if you wanted to increment the counter by 1, Scratch uses the verb change, and they mean add the value to counter. So if I want to increment an existing variable called counter, this syntax is a little more interesting. It turns out the code looks like this, which almost seems like a paradox, like how can counter equal counter plus 1? Like that's not how math works. But again, a single equal sign is assignment from right to left. So this is saying take whatever the value of counter is, add 1 to it, and copy that value from right to left into counter itself. You still need the semicolon, but I claim you do not need to mention the keyword int when updating an existing variable. So only when you create a variable in C do you use the word string or the word int or any of the others we'll eventually see. Only when creating it or initializing it for the first time. Thereafter, if you want to change it, it just exists. It's the word you gave it. The computer's smart enough to at least remember what type it is. So this line is now complete. Turns out in code, as we'll see, it's pretty common to want to add things together, increment things by 1. So there's actually different syntax for the same idea. The term of art here is syntactic sugar. Like there's often in code many ways to do the same thing, even though at the end of the day they do exactly the same functionality. So for instance, if after a few days of CS50 you find this a little tedious to keep typing in some program, you can simplify it to just this. This is the syntactic sugar. You can use plus equals and only mention the variable name once on the left, and it just knows that that means the previous thing. It's just slightly more succinct. This, too, is such a common thing to add 1 to a value. And it doesn't have to be 1, but in this case it is. But if it is indeed 1, you can further tighten the code up to just do this, counter plus plus. So anytime in C you see plus plus, it means literally adding 1 to that particular variable. There's other ways to do this in the other direction. If you want to subtract 1 from a variable, you can use any of the previous syntax using a minus sign instead of plus, or you can more succinctly do counter minus minus. This is the way a typical C programmer would do this. All right, so if we have now variables, let's go and solve the meowing with loops. So in Scratch, we saw loops like this. This, of course, had the cat meow 3 times. How do we do this in C? Now, this is where things get a little more involved code-wise, but if you understand each and every line, it will follow logically what's going on. So here I claim is one way to implement a loop that iterates 3 times in C. And this is kind of ridiculous, right? Like we went from 2 super simple puzzle pieces like this to, my God, like it's 1, 2, 3, 4, 5, 6 lines of code, all of which are pretty involved. So like that escalated quickly. But what's each line doing? And we'll see other ways to do this more simply. So we're initializing a variable called counter to 3, just like before. Why? Well, what does it mean to loop or to repeat something 3 times? Well, it's kind of like doing something 3 times and then do it, and then count down, and then do it, and then count down, and then do it until you're all out of counts. So this is declaring a variable called counter, setting it equal to 3. Then I'm inducing a loop in C, which is similar in spirit to repeat 3, but you have to do more of the math yourself. So I'm asking the question in parentheses, while counter is greater than 0. What do I want to do? Well, per the indentation inside the curly braces, I want to meow 1 time. And then to be clear, what's this last line of code doing? If counter starts off at 3, this makes it 2 by subtracting 1 from it. Then what happens? By nature of a loop, just like in Scratch, it kind of knows to go back and forth, even though there's a nice pretty arrow in Scratch and there isn't here. C knows to do this again and again and again, constantly asking this question and then updating this value at the end. So if I highlight just a few of these steps, the variable starts off at 3. And actually, let me simplify too. I claimed earlier that When using single variables, people very often just call it I for int, or C for char, or S for string, unless you have multiple variables. So let me tighten the code up. And this already makes it look a little more tolerable. Let me actually tighten it up further, and one more step. So now this is about as tight, as succinct as you can make this code at the moment. So what's actually going to happen here? Well, the first line of code executes, and that initializes I to 3. Then we check the condition. While I is greater than 0. Is I greater than 0? Well, per my 3 fingers, obviously. So we print out meow on the screen. Then we subtract 1 from I, at which point now we have 2 as the value of I. Then the code goes back to the condition. And notice the condition there is in parentheses. That's another Boolean expression. So loops can use Boolean expressions, just like conditionals use Boolean expressions to make decisions. The loop, though, is deciding not whether to do this thing or that, but whether to do the same thing again and again and again. And as it ticks through the code one line after the other, it's ultimately going to get down to 1 and then 0 and then stop. So put another way, came with some props here. So suppose this ball here is your variable, and you initialize it to 3 with like 3 stress balls. You can do something 3 times, right? If I want to give out 3 stress balls, here's your chance for free stress balls without having to answer any questions. OK, there we go. So here we go. Subtracting 1 from my variable. I'm left with 2. Oh my God. All right. Don't tell Sanders. Oh, I'm sorry. Oh, OK. That ended poorly. Apologies. All right, but now the educational point, though, is that my variable has been decremented further to just have. I'm not throwing that far again. I can't do this. Here we go. All right, here we go. And one final subtraction, and now our variable is left empty. So we have 3 stress balls there, and that's all a variable is, right? It's some kind of storage. It's actually, of course, implemented in the computer's memory. But metaphorically, it's really just like a bowl with some values. And every time you add, or in this case subtract, you're just changing the value of that variable. And then the code, meanwhile, of course, in parentheses, is just checking, is the bowl empty? Is the bowl empty? Is the bowl empty? AKA, is I greater than 0 or not? Any questions on how we've implemented loops in this way? And I owe you a stress ball after class. Questions on loops? All right, so it turns out this is kind of ugly. And like this really starts to take the fun out of programming when you have to like write out this sequence of steps. So it turns out there's other ways to do this. But first, let's see logically how else you might express this, because it's a little weird that we keep using 0. So the one other way to do this would be to invert the logic. You could absolutely start with your variable, call it I, equal to 1. And then you could ask the question, is I less than or equal to 3? And notice a bit of new syntax here. On your typical keyboard, there is no less than or equal sign or greater than or equal sign like you would write in math class with one over the other. And so in C, you use 2 characters, less than followed by an equal sign, or if appropriate, greater than followed by an equal sign. And that logically captures that idea. So notice that I'm kind of changing my questions. I'm initializing I to 1, and then I'm going to increment it ultimately to 2, and then 3. But because I'm doing less than or equal to, it's still going to go from 1 to 3. So that works too. We could similarly do this yet another way. We could initialize I to 0, and then we could say, well, I is less than 3 and keep incrementing it. And I showed this last form as actually the most canonical. Like it might be the most human-like to think in terms of 1 to 3. It might be the most stress ball-like to think in terms of 3 to 0, counting down. But typically, the go-to syntax for most programmers, once you get comfortable counting from 0, is to always start counting from 0 and count up to less than the value you're counting up to. So it would be incorrect Y to change this to less than or equal to 3 here. What would happen if I changed the less than to less than or equal to? Yeah, it'll meow a 4th time, in fact, total, right? Because you'll start at 0, then 1, then 2, then 3. And less than or equal to 3 will give you the 4th time. So we do want it indeed to be just a single less than. All right, so now that we have those options, let me just give you one other. And this one takes a little more getting used to as well, but it's probably the more common way to write this. Let me go ahead and propose that we implement this as follows. Let me go back to my code here. Let me go into my several printfs, getting rid of all but one of them ultimately. And let's implement this in code. So let's do int I gets 0. How about then while I is less than 3, Then let's go ahead and say printf, quote unquote, mellow, meow, \n. And then we have to do I minus minus or plus plus? So plus plus, because we're starting at 0 and going up 2, but not through 3. So let me go ahead now and make meow after clearing my terminal, /meow. And it's still just as correct, but it's a little more, it's a little better designed. Why? Because now if I want to change it from 3 to 30 times, for instance, I can change it there. I can recompile my code. I can do /meow and done. I don't have to copy and paste it 27 more times to get that effect. And I can even change what the word is by changing it in just one location. But it turns out there's other ways to do this too. And let me propose that we introduce you to what's called a for loop as well. So if you want to repeat something 3 times, you can absolutely take the while loop approach that we just saw. Or you can do this. And this one's takes a little more getting used to, but it kind of consolidates into one line all of the same logic. So notice we have the keyword for here. And for is just a preposition in this case that generally implies here comes a loop. Inside of parentheses here is not just a Boolean expression. And this is where things get a little weird. There's 3 things. To the left of the semicolon, in the middle of the 2 semicolons, and to the right of the semicolon. This is really the only other context we'll see semicolons, and it's weird. Normally it's been at the end of the line. Now it's 2 of them in the middle of the line, but this is the way humans decided years ago to do it. So what is this doing? Almost the same thing. It is going to initialize a variable called I to 0. It's going to then check if it's less than 3. It's then going to do whatever in the curly braces. And it's lastly going to increment I and repeat. So just highlighting those in turn, at first, I is initialized to 0, just like before. Then this condition is checked. This is a Boolean expression. Yes or no, true or false will be its answer. And if I is less than 3, which it should be once it starts at 0, well, then we're going to go ahead and print out meow. Then I is going to get incremented. So it starts at 0. It goes now to 1. At that point, the Boolean expression is checked again. So you don't keep changing I back to 0. That first step happens only once. But now you repeat through those 3 other highlights. I check if I is less than 3. It is. So I print out meow. It then increments I. I check if I, now 2, is less than 3. It is. I print out meow. I gets incremented. I now check. Is I less than 3? No, it's not. Because 3 is not less than 3. And so the whole thing stops. And whatever code is below this curly brace, if any, starts executing instead. Just like in Scratch, you break out of the loop and the puzzle pieces being hugged. Questions then about this alternative syntax for loops, aka a for loop. Sorry, say again? Yeah, can I explain again why it doesn't reset to 0? Honestly, just because. Like, this was the syntax they chose. This first part before the first semicolon is only executed once, just because. That's how it's designed. Everything else cycles again and again. And this is just an alternative syntax to using the slightly more lines of code. It was like 6 lines of code using the while loop. Logically, it's the same thing. Programmers, once they get more comfortable, tend to prefer this because it just expresses all your same thoughts more succinctly. That's all. Yeah. OK, so let's just work this into my meow example. Let me go back to the code here. And notice, indeed, if I highlight all these lines, I think we can tighten this up. Let me get rid of all of those and instead do for int I equals 0. And I'm saying equals. Most programmers would say gets. So int I gets 0 means assignment. The word get. Now I'm going to do I is less than 3, I plus plus. Now in here, I'm going to do my printf, quote unquote, meow \n. And so it's indeed a little tighter. I mean, 2 of the lines are just curly braces. There's really only 2 juicy lines of code now. Let me go ahead and do make meow /meow. And again, we're back in business with 3 of them printing only. All right, there's one last structure we should explore just because it's sometimes useful. This was a forever block. And this would be a little weird in Scratch to just say meow forever, at least without waiting. But there is indeed a forever block in Scratch, which means do the following forever. And I proposed, I think verbally last week, at least one example where this is useful. Meowing forever, a little annoying. But can you think of common cases where you might want to write code or use a program that loops forever? Yeah. Yeah, playing music. Like a Spotify playlist just repeating again and again would be some kind of loop. Checking for collisions in Scratch. So seeing if something's bouncing off the wall or another sprite. Yeah. Checking for input. So yeah, get string is essentially just waiting there forever for me to type in some input until I do. Checking the time and actually maintaining like human time, like a wall clock behind you. Is that the same? OK, checking the time. And one more. Sorry, a little louder. Detecting a key press, too, like in Scratch, just waiting for some kind of event to happen, just like on a phone or a browser. And so there's so many examples where you might want to do something forever, just so you've seen the corresponding C building block. It's a little weird, but this is probably the most canonical way to do it in C. If you want to print meow forever, which would be a little crazy because it would literally print and take over your computer, printing forever meow, you would generally do it like this. Why? Well, a while loop expects in parentheses a Boolean expression. And a Boolean expression is, again, a yes-no, a true-false question. But if you want the answer to that question always to be yes, or really always to be true, turns out in C, in a lot of languages, we'll then just say true. Because true, T-R-U-E, is never going to change magically to false. I mean, it's just a special word in the programming language. So by saying while true, it just means do the following forever. Another common paradigm before true and false became commonplace would be to do this instead. Change while one. You might see in online examples and texts and the like. While one is really the same thing. Any value that is 0 is generally interpreted as false by a computer. Any value that is 1 or any other non-zero value is generally interpreted as true. And so this, too, would have the same effect, saying while true or while 1. Generally speaking, while true is perhaps a little clearer these days. Now, meowing forever is not a good thing. But suppose I did that by intent or by accident. Well, let's try this. So here I'll go into my code. I'm going to get rid of my for loop and change my while loop to how about true? And in this case here, well, we'll keep it. Let's do this. Make meow, enter, and you'll see this. Use of undeclared identifier true. This is actually hinting at my mention that the old way was 0 and 1. Nowadays, you could say true or false. But true and false are themselves special words that you have to include. And it turns out if you want to use special Boolean values like this, there's another header file we haven't seen called standard bool that essentially creates true and false as keywords. Alternatively, CS50 includes that same file, so it's more common in CS50 to see it like this. Now, if I clear my terminal window and do make meow and then /meow and hit enter, well, unfortunately, this isn't the best thing to do infinitely when you're in the cloud using a browser. This is indeed browser, just full screened here. This means I'm sending millions of meows over the internet to my computer here. So this will happen to you at some point. Probably not with meow, but you'll lose control over your terminal window. Why? Because you screwed up and like you have an infinite loop. You didn't really intend it. Or maybe you did. You were curious to see what happens. What do? Like, when does the meowing stop? What recourse do we have here? All right, well, Control-C will be your friend. Sometimes you have to hit it a bunch in a cloud environment, but Control-C for cancel will interrupt a program that's running. And I promise that almost all of you will at some point accidentally introduce an infinite loop because your math is slightly off. When in doubt, click in the terminal window and hit Control-C, sometimes multiple times, and that will indeed cancel whatever is happening there. In this case, I might have intended it, but sometimes it's not, in fact, intended. All right, so we've been taking for granted this whole graphical user interface for some time. And indeed, the commands that I'm typing and the buttons that I'm clicking. And let me just give you a better sense of what it is we are using underneath the hood this whole time, namely an operating system called Linux. So I keep alluding verbally, of course, to Macs and PCs, because almost all of us are running Mac OS or Windows on our desktops or laptops nowadays. But there's lots of other operating systems out there. And one of the most popular one is called Linux. And Linux is very often used on servers nowadays, companies that host email, companies that host websites or apps more generally. Certain computer scientists or computer science students often like to brag that they run Linux just because that's a thing. But it is really just an alternative to Mac OS or Windows that provides you with both a GUI, if you want it, but also and especially a command line environment. Now, fun fact, Windows and Mac OS do have terminal windows or the equivalent thereof. And eventually, you might use it on your own Mac or PC to solve some problem. But Linux is really known for, along with other operating systems, its command line environment. environment, which again I distinguished earlier from GUI as a command line interface, or CLI. And that refers really to the terminal window. So if I go back to VS Code here, and let me, in fact, go ahead and close my tab and focus entirely on the terminal window. This terminal window is really just your command line interface to your very own server in the cloud. The term of art here is you each will have your own container in the cloud, which is like your own computer running somewhere on the internet with your own username and password to which you have access, and your own hard drive, if you will, your own home folder that has all of your files for the class, and it's only accessible to you unless you enable live sharing thereof. So when you're typing commands here, it looks like you're typing them, of course, on your own Mac or PC, but they're actually being sent over the browser to some server in the cloud, where you are controlling really your own account therein. So it turns out that there are other commands that are worth knowing. And we'll give you just a few of these today. And over the coming weeks, we'll have opportunities to play with others as well. But these are kind of some of the basics. And they're all incredibly succinct. Because indeed, for things you're typing at the command line, humans generally have not wanted to type out long commands. So a lot of these are abbreviations here. Now, perhaps the most common one I'll start with first is ls, a lowercase l and a lowercase s. That stands for, succinctly, list. So if I go to my terminal window now, where up until now I've only typed code, which is a VS Code thing for creating and opening files, and make, which triggers the compilation of my code, what if I now type ls? This will list all of the files in my current folder, my hard drive in the cloud, if you will. So if I hit enter, you'll see a whole bunch of results. Now they're color-coded too. The white ones here end in .c. Those are the source code files I've written during class today. Agree.c, compare.c, hello.c, and meow.c. And you can perhaps guess the green ones here, that just by convention have an asterisk on the end to denote that they're special, represent what? What are the four others? Yeah. Yeah. The machine code. So those are my actual programs that are identically named minus the .c extension. And the asterisk means that they're executable. That is, in the world of Mac OS or Windows, you would double click. But in the world of a command line environment, that means you do / and then the name without the asterisk to execute or run the code therein. So if I open up my File Explorer, and I'm hitting Command B on my computer here just as a keyboard shortcut, you'll see the exact same thing. So ls is the command line interface for listing the files in your account. But here, because I'm using VS Code or any program like it, I also get a graphical user interface as well. So it's just two different places to be. You're welcome to use whatever you're comfortable with, but over time, will you naturally get more comfortable and capable with the terminal window alone? Well, what else is on this list here? Well, during the break, I saw that a few of you had honestly made some typos. Super common. I saw some incorrect capitalization of files. So suppose I did that myself. Suppose I go back to VS Code and rewind to the start of class, and maybe I accidentally, just by kind of convention, typed hello.c with a capital H. You know, that's not a huge deal. And in fact, we try to detect that. We're showing you, are you sure you want to create hello.c? File names aren't usually capitalized. You like things the way you like them, so you hit Y, enter. Here's now a file called hello.c. And if in hello.c I do include standard.io.h, int main, void, and then inside here I do my printf, quote unquote, hello world, \n. If I go to try to compile this, make hello, this, of course, oh, damn it. It's case insensitive, isn't it? Did not expect that. Let me rewind. Suppose, OK. During break, I noticed that some of you had miscapitalized or misnamed some of your files. And for instance, I saw that one of the files was named just hello instead of hello.c. Suppose you did that then. Suppose you, oh, this isn't going to work either. One sec. hello.c. OK. During break, I noticed that a couple of you had misnamed or miscapitalized your files. And at least one of you, for instance, had created a file called hello instead of hello.c. So you were in a situation where you did this accidentally and hit enter. And then you went ahead and typed in all of your code like this. And then down in your terminal window, you were trying to do make hello enter. And this now didn't actually do anything. Like I'm trying to run the command. I got permission denied, as at least one of you did. Now, why is that? Well, let's just do a quick check. If I do ls, I see now hello but hello has no asterisk next to it, which means it's not executable. That's my code. Why? Well, notice the top of my tab confirms, oh, I screwed up. I didn't name my file hello.c, which it just has to be. So what do? Well, you could very hackishly like copy this, create a new file, paste it in, or no. Like we know how to rename things now here, because that's one of our options. Let me do this. Let me do mv for move, hello, and then hello.c, and hit enter. You'll see the tab closes because hello no longer exists. But if I now type ls, you'll see, there is hello.c. And if I open that file now, there's all of my same code. And now if I do make hello, now I do get an executable file wherein the world is restored. So mv is just a command not just for renaming, but it also turns out eventually for moving files as well. You can also create directories or folders. So for instance, if I go into VS Code again, and suppose I hover over here and click not on the plus file icon, but plus folder, I can create a folder called, for instance, like pset1 for problem set 1 in the class. And you'll see now that it's empty because all of my other files are in the default folder of my account. But I could also go in there like this, and I could click on File. And now I can create a new file called like mario.c, which is one of the first problems, for instance. But you'll notice now that mario.c is inside of the pset1 folder. So if I zoom out and I type ls at my terminal window, I won't see mario.c anywhere. But I do see a pset1 folder. And it's in light blue followed by a slash, which you don't have to type. It just indicates that's a folder. Now, I can visually at top left obviously see pset1 contains mario.c. But if I try to do something like make Mario here, no rule to make target Mario, like it just doesn't seem to exist. And that's because you're in the wrong directory. So in a command line interface, it's not quite as simple as just clicking on a folder and voila, it opens. You have to change into the directory or folder, and cd is going to be the command there. So if I want to actually change into that directory, I can do cd space pset1, enter. And now you'll see my prompt changes. And this is just a common convention, but it's not the only one out there. Now I still have a $, which indicates where I can type commands. But before it, I see a reminder constantly what folder I'm in. And we put that there deliberately, like a lot of Linux users do, just to remind themselves where they are. Because unlike Mac OS or Windows, where you have a nice big window telling you where you are, at the command line, you kind of need to be reminded textually. But now if I type ls and hit enter, what should I see? Yeah, mario.c. And now if I want to open it, if I want to actually compile it, I can run make Mario in this directory once I actually type out all of the code. Rest assured that in problem sets in labs, we'll almost always, certainly in the first weeks of the class, give you exactly the commands to type. Odds are, because it's new to many of you, you will accidentally type the wrong commands. No big deal. Just remember that you have different ways to solve these problems. You've got like the graphical file explorer, which should feel a little more familiar. But in time, you'll start to know and honestly probably prefer commands like these. So cd for change directory, cp for copy a file, ls for list, mkdir to make a directory, create a new folder at the command line instead of with the button, mv for move or rename, rm for remove. So be careful with that one. rmdir, remove directory. And there's dozens, hundreds of other commands. You won't need many of them, but we'll start to scratch the surface all the more over time. But ultimately, this command line interface is going to be a more powerful mechanism, a more capable mechanism, and ultimately a more efficient mechanism for writing code, running commands, solving problems, analyzing data more generally, even though, there's going to be some growing pains early on, just because it's probably so new for many of you. So with that said, we have some problems still to solve, but we promised cookies today. So let's go ahead and take a 10-minute break. Cookies are now served in the transept, and we'll be back here in 10.